हेलो। 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 हेलो।
ये तो है आवाज।
ये तो आवाज ठीक है सर। क्या करें? ठीक है, कर दो सर, मैं स्टार्ट।
यस सर।
ओके। गुड आफ्टरनून एवरीवन। तो एम आई ऑडिबल टू एवरीवन?
येस सर,
ये
येस सर.
सुमय्या मॅडम रेकॉर्डिंग आणि ते हे करून घ्या स्टार्ट
हो सर.
लाईव्ह हो.
सर एक अराउंड 1 आवरचं 45 मिनिट टू 1 आवर पर्यंत ना?
येस येस.
ओके.
येस सर.
आता मी जेवढे जमले तेवढं फास्ट केलंय, पीपीटी वगैरे आहे.
चालतंय सर, काय अडचण नाही.
तर काल काय तो प्रॉब्लेम आला लॅपटॉपचा. So hello everyone. During organic synthesis or research methodology, there are very different conditions we required for research purpose, like
सर फुल
solvent.
फुल स्क्रीन करा ना त्याला.
Uh,
येस.
like for we use different solvents, different catalyst, different temperature. So as you have all been involved in research from maybe past 6 months or maybe past 1 or 2 years. So definitely you have tried many different conditions for research purpose. You have already maybe searched different journals. So there are different terms in organic synthesis, like you can monitor different temperature for reaction conditions. So when I was doing research in IIT Bombay, at that time we used to monitor different reaction catalysis conditions. So I was involved in furan synthesis, uh, which was in the year of 2017 and 2018. 2018. So at that time, we were doing furan synthesis and monitoring different catalysts. So that used different protecting group as well as different reaction condition. Like what? So I used to set up reaction at around 10 degree, 20 degree, 30 degree. So at a time, I used to set many reaction like 12 to 13 setup and monitor number of what yield we get. So for that purpose, many different protecting groups we have to use for protecting or block the reaction conditions. Like reduce selectivity, we have to operate reduce selectivity in the reaction. So we will see like some protection over here, and if we have some time, we will try to see another reaction methodology, research methodology, which we have or which may learn. So for protection purpose, there are many different protection or protecting groups we can use. For example, we have alcohol. So for alcohol, you can protect alcohol in methyl protection. So for alcohol reaction, let's say we have OH and we use base and benzyl bromide. So this protection for alcohol is used when you have like reducing agent as a deprotoning agent. Means next during next step what you can do. So first you have to protect alcohol which you don't want to react with your reaction condition, right? If you have alcohol, ketone, and also you have acidic functional group, so you have to do reaction at acidic functional group, and you have alcohol also. So there might be chance can alcohol can attack that electrophile, or it can react with or it can give cyclization reaction also. So if there is large enough ring or large enough straight chain carbon, so it can form a large ring with ester in with involved ester formation. So if you use alcohol protection, for example, we have taken sodium hydride and benzyl bromide as a protecting group. So it will form benzyl protection. So what is use of benzyl protection? If you are doing reduction in the next step, next further step, you can deprotect it by using PDC, nickel, and sodium liquid. So means this benzyl protection is easily deprotected in presence of catalytic protecting group, deprotecting group. So you can have alcohol protected, and you can do such other organic reactions. You have to, like, if you have to do the reaction at nitrogen or oxygen or other functional group during your reaction or during your reaction setup, so you can protect this functional group and do the reaction at other part. So, like, you will see one example over here. Let us consider we have this OH. So for reduction purpose, you can use NaBH4, right? And this ketone can get reduced into secondary alcohol. Let's say we reduce this alcohol. We don't know the stereochemistry, right? It may be above or it may be below. It depends upon this OH functional group, right? So if you want this OH group selectively above or below, you can protect this OH group, right? And during protection, you can use large group or small group. So that may impart selectivity at this reduction reaction. So why protecting group is necessary? Because if you have to do the selectively reaction, or if you have to increase the yield, you can block one of the, like, steric hindrance or steric hinder group, and you can open another reaction site for reduction purpose. So here we can protect this group or do the reaction over here. So it can give you required alcohol. Like you have benzyl. So benzyl can easily deprotect in forms of H2PDC. Okay. So next we have tertiary butyl protection. So what it suggests, tertiary butyl protection? Definitely tertiary butyl group is one of the bulky group. So it has very important role in protection because
तो मग
bulkiness.
वाला असेल बघ.
See, tertiary butyl group is one of the bulky group. So if you have different alcohol, like you have primary alcohol, you have tertiary alcohol, definitely there might be different, or there may be
आला
difference
का?
in their reactivity, right? So let's say we have primary alcohol here, or we have tertiary alcohol here. You have different group, barabar? So where it will react? Tertiary butyl group, where it will react? It depends upon the reactivity. But definitely it will react at primary alcohol first due to its bulky nature. Yes or no? Hello?
Yes, sir.
Right?
कपडे बदल.
So definitely it is going to react at primary
Personal loan.
alcohol. If it react with
मला
primary
असं
alcohol,
करायचं.
so definitely you get selectivity. Means this tertiary alcohol get deprotected. You can do reaction over here. You can have an elimination reaction over here. You can have another electrophilic substitution, or you can have another cyclization reaction over here. So it is also, like, very well stable to nucleophilic and hydrolysis condition. So if you are doing hydrolysis condition, so this may be a best chance you have to use during your synthesis reaction,
बस.
right?
हो चालेल.
So that may help you during your protection and deprotection. Okay. Then another one is, which is another ether form, multi-ether form protection synthesis, right? Benzyl oxymethyl ether protection. Again, we have alcohol group.
वाजू नको रे. ए तिकडे जा
So
थोडा वेळ. कपडे
this
बदल.
alcohol group is protected in presence of generally nitrogen containing base. So if you are using bomb protection, you have to use mainly secondary amines as a base for reaction catalysis. Okay.
नको रे.
So definitely what will happen, this OH will react that this carbon, and it will get protected in form of BOM. So see, here we have also benzyl group. And you have to remember one thing, like whenever you are using benzyl protection, you have to avoid catalytic condition most of the times. catalytic condition in terms of sodium liter, sodium liquid birch reduction जो रहता है, बराबर. और you have like H2PTO2 Adams catalyst,
हेलो.
palladium
हाँ,
hydroxide.
रेहाना बोलो.
Okay, so
मैं घर पे हूँ.
you have to avoid
कि-
you have to avoid catalytic reduction so that you can get better yield, or you can have, or you can avoid whatever side reaction occurring during your synthesis reactions. Okay, so let us consider you have protected both OH. You have protected this OH by normal benzyl group, and you are protecting this OH in terms of like bonds here. So what will happen? Selectivity, you have to use selectivity over here, right? Means, sorry, your benzyl protection as well as BOM protection. So let us consider you have to do reaction over here. So you have to selectively deprotect this one. So first you have to protect OH group, right? And then deprotect this benzyl group. So which reagent you can use over here? You have to decide, right? So by deciding that reagent, you can deprotect this OBN and do reaction over here. So you will get your required product and you will have your better yield for your reaction. So bomb and OBN. So for using selectivity over here, see they have already given another catalyst, like this is not used for OBN protection. For benzyl group protection, you have H2 PDC catalyst. Okay. And if you use palladium hydroxide, so you can deprotect OBM, OBOM, benzyl oxymethyl, Na in liquid ammonia. This it will deprotect both OBN as well as BOM and H2PTO. So like palladium catalyst deprotect both OBN as well as BOM. So you have to use proper deprotecting reagent for your required reaction condition, right? So that is most necessary part during protection. So why protection and deprotection is necessary? Because it decreases your yield, because at the end you require certain yield for your product, right? So for deprotecting OPN and BOM at us like selectively, so you may suffer loss of yield. Why? Why? Because BOM and OBN have quite similarity. You have to use selectivity during their deprotection, right? So you can use like cyclohexadiene, sodium in liquid ammonia, but sodium in liquid ammonia is common in both of them. So you have to use cyclohexadiene, cyclohexadiene at H2PD or H2PT. So it may help to deprotect this OBN group. Okay. Then another one which includes paramethoxybenzene. This type of protecting groups are mostly involved in sugar chemistry, carbohydrates, mostly used in carbohydrates research. So during carbohydrate research, there are many OH groups. So we have example over here, right? So definitely OH group can get protected in many different protecting groups such as methyl, tryl, benzene, then silicon containing protection which uses silicon like TBDMS, TMS, TIPS, TIPS, triisopropyl silicate. So it has different deprotecting agent. One is DDQ and another one is CAN, ferric ammonium nitrate, right? So see, we have one example over here. All five free OH group from this sugar moiety is protected. You can see 5 protecting group. So you can remove all by like proper deprotecting reagent. So such as we have over here BOM as well as PMB paramethoxybenzene as well as OPN, OTBDMS, OTTL. What is important? See, each each protecting group has their like own property. So you cannot use a simple reagent to deprotect all OH group, right? So let's say we have to deprotect this PMB, paramethoxybenzene group. What we will do? We will do PMB. So without affecting other protecting groups such as OBN, OPTBDMS, TTL, then benzyl oxymethyl, this OH get free, right? Because this hemiacetal carbon is protected in the form of benzyl oxymethyl ether protection form. So that's why in sugar chemistry, without protection, you cannot do many reactions. So this is common step in sugar. If you are doing research in carbohydrate chemistry, so you have to do lot of protection and deprotection. And for that, lot of protection, deprotection, you will require many reaction condition like you will use acidic condition or basic condition. So acidic condition may get open this hemiacetal linkage or give you a regular carbohydrate structures containing aldehyde or ketone functional group and 5 OH group might be. So you have to use selectivity. You can deprotect this TBDMS also. Or maybe you have seen or you have learned in MSc or during net set preparation, gate or PET preparation. So TBDMS you can deprotect by fluoride. Fluoride source is best source for deprotecting TBDMS reagent, right? So you may deprotect it by using TBAF as a deprotecting agent, right? Another example here. Here, see 1, 2, 3, 4, 5, and 6. So here we have 6 OH group again, and all are protected in different protecting zone. So like oxygen is protected in the form of MOM. It is again etheric protection. MEM again same protection, ether protection. PMB paramethoxybenzyl protection, benzyl protection, and this is quite 1,2-diol protection by acetone. So see, this is CH3, 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 and CO wala protection. Okay. So what will happen again if we have to deprotect selectively PMB? So we have used here DDQ. So it will free this PMB only, and other group are as it is. So during multi-protection synthesis or during multifunctional group, you have to selectively like you have to use one by one methodology. So how this moiety get protected? Anyone? Like during protection, see here already structure. I have written already structure. But the main thing is what during your research you have to protect all these functional group. Barabar. So for protecting this functional, we have to use selectivity again. You have to protect this group by OBN. You have to protect then next group by PMB. Then this secondary, both these three are secondary alcohol. You have to protect selectively. So you have to use, yes, someone raised hand. Hello, any doubt? Okay,
Sir, please continue, sir.
okay. So you can protect one by one, or you can use different methodology. Like what you can first protect 1 and 2, like this 1,2-diol, or you can protect this 1,3-diol, then protect this. If you have protected 1 and 3 diol group, then you can protect this OH group. You have to use different strategies for protecting purpose. If you are doing protection, deprotection, or if you are doing glycochemistry as your research part, okay. Then there is TTL protection. So again, it is bulky protection because TTL is like we have three phenyl group over here, and this three phenyl group can protect primary alcohol selectively in presence of secondary and tertiary. So it is important. Already I asked you, what will you do? So see, we have primary carbon over here, right? What we have here, primary carbon. This is primary carbon. And we have secondary, tertiary, secondary, and again secondary carbon. So four are secondary carbon. You have to selectively protect this functional group first. You may use TT, then protect this secondary by other functional group, other protecting group. Then deprotect this one, OBN, like by we have protected by TT, and again use other PMB ether. So same will happen here. See, we have example over here. This is primary, this is secondary. This is I am talking about, this thing I am talking about. So if you use trityl group, it will selectively protect only primary alcohol. Secondary alcohol will remain as it is. It will not affect secondary alcohol. So why? Because secondary alcohol is less reactive towards this tertiary carbon, which have which has three phenyl group, right? So again, we can deprotect it in acidic condition in silyl bromide, like PTSA, dry acid comparatively, and H2PDC. So deprotecting it in it is easy. So we can use acidic condition as well as like catalytic reduction, right? Then we have another MOM, methoxymethyl protection. So it is used in several protecting or several reactions. See, again, it may protect primary, secondary, tertiary alcohol. All of them you can protect all of them, and you can deprotect it in acidic condition. Simple. So there is no need to like use harsh condition. Concentrated HCl, CF3COH is strong acid comparatively. So you can use concentrated acid, concentrated HCl, and PPTS. Okay. Then amine. So maybe many of you have been involved in amide synthesis in research purpose. Amide. So during amide protection, like peptide or other different groups, protection of amine is most necessary part. So you can have protected in carbamate or silicon, but most important, or we can say most useful for protection of amine is carbamate protection. You can use this protecting group for alcohol also. So like this is carbamate. So you if you protect it in the form of alcohol, it will form you carbonate. Okay. Yes, ma'am. Any doubt, Thakur ma'am? Okay. So if you have no doubt, then we will continue. Okay, ma'am. See, protection of amine is used in the form of, or for better yield, you use carbamate protection. You have different protecting strategy. Like what? You can use like methyl protection. You can use silicon protection. Okay. So you can use trityl protection. Whichever you have seen in alcohol protection, you can use over here also. But for protection of amine, or you can say in peptide synthesis, protecting it in the form of carbamate is most important concept or most important thing, because it will give you stability or it will give you the better yield. So avoid further deprotection or avoid further like definitely it has many polar group in protein or in peptide synthesis. So like COOH, there are aspartic acid, glutamic acid. Again, it has basic functional moieties, lysine, arginine. So it will definitely hinder their stability. and you have to again control the pH during protein synthesis or during amide or peptide bond. So you may use this carbamate protection, which are different. Like what one of many stable carbamate protections are EPMOC, TROC, then BOX, CPZ. Okay, you have different methyl carbamate, CPZ, so benzyl carbamate. These protecting groups are useful. See, I have written over here benzylamine. You can use benzylamine or sorry, we have allylamine as well as tritilamine. So amide or amine can be get protected into many carbamate protecting groups. We will see here. First, let's say we are using methyl or ethyl carbamate protection. Okay. So during basic condition, we use like amine with chlorocarbonyl. So it will get protected in presence of weak base like etithricin or potassium carbonate and get protected in the form of carbamate. So why it is important? Because it is susceptible to acidic condition. See, there is no acidic condition here, right? So it gets it is stable at acidic condition. So if you want to use some weak or harsh acidic condition, you can use during this protection. Same for CBZ group. So CBZ group Cl or during peptide synthesis we can use. Again, amine get protected in form of this protecting group. So which will form you carbamate again, which is very well stable. Okay. So what is important? It's deprotection. So you can see I have written deprotecting agent. So all are like catalytic protecting deprotecting group. Important part is what? It is stable in acidic condition again. So acidic and quite basic condition. So it is like stable. Most of this carbamate protecting group are stable in acidic condition. So you want to like hold that ring or hold that hydrogen bonding group for stability purpose. Hence, for protection of amine, carbamate is best protecting group or best protecting strategy. So you can use in your research purpose. You can try different carbamate protection. So we have CBZ first, right? First we have seen methyl carbamate or then CBZ. So benzyl oxycarbonyl group, like we have benzyl group over here or CO. So already we can deprotect this benzyl again. Again benzyl group here. So we have catalytic deprotecting agent. Catalytic means bulk reduction again, H2PDC, and we have BBR3, Lewis acid, or bromocatechol borane. So borane are also useful for this deprotection. Okay, because boron can react with oxygen or nitrogen and get deprotected this functional group. Okay, see one example is here. Let's say we have protected many functional group like oxygen is protected, OBN is protected, and you have to deprotect only this CBZ. But you cannot use H2Li, H2PDC, barabar. You cannot use this three deprotecting group. Why? Because if you use H2PD, it will deprotect this as well as this functional group. This OBN will become OH and this NHCBZ will become NH2. You have to selectively deprotect this. So you have to think about other functional group also. When you get protect other functional group. So which group is involved during protection? So if you use OBN and again you have protected some other part by CPZ, so you cannot use catalytic deprotecting reagent like Li liquid ammonia H2PDC because it will deprotect both OBN as well as CBZ. So that may result in different product or there might be side reaction. So there might be cyclation if you have any electrophilic carbonyl group like acid chloride ester or aldehyde ketones or acid. Okay. Then another one is you can use triethylsilyl in presence of palladium. So there is no reduction because H2 and PD can reduce this double bond also. Barabar. So if you have unsaturated moiety or unsaturated side chain in your starting material or intermediate, and you are using H2PDC as a deprotecting reagent. So what will happen? You require, let's say you require this double bond and you are using this H2PDC. It will deprotect this as well as reduce this double bond. So unsaturated ring will become saturated and you will get different moiety, different product, different intermediate. Barabar. So that will changes its property again. And you may get different property to different structures depending on the reaction condition and depending on your starting moiety. Then next is Bach protection. It is also very strong protecting group, so quietly stable and resistant to nucleophilic reagent. So this carbamate again, it is also carbamate NHC double bond OO. This carbamate is very well stable to nucleophilic reagent. Like what? Let's say you have to do Grignard reagent or organolithium reagent. So what will happen? You can easily do in presence of this carbamate. It will not react at carbamate. Grignard reagent and butyl lithium will not easily break this carbamate. Okay. You have to use strongly acidic conditions. So you have TFA, trifluoroacetic acid, which is very strong acid. Okay. Barabar. You can use different solvent. So solvent may affect your yield. You have to check your starting moiety depending upon the polar functional group. You may use different polar solvent. But see, we have DCM here, right? So changing solvent may also affect your yield. So that's why this is important. They have given three different conditions. Why? Because some of the functional group may get deprotected in this solvent, some of may not. That's why they have used different reaction condition which have deprotected this Bock functional group. Then next is EPMOC. One example is here. So three OH group, first one, this second one, two OH group and one amine group is get protected in this example. So we have TBDMS. TBDMS means silicon based protecting group. Okay. We have ester protection simple, acetate, and another one is carbamate. So you can deprotect this TBDMS easily, but silicon protecting groups are slightly susceptible in strongly acidic condition. Strongly acidic condition may deprotect this group. Okay, strongly means sometimes if you use strong H2SO4 or HCl, so it may get deprotected, but not easily. TMS is very susceptible to acidic condition, like SiCH3 thrice, which is very weak in terms of protecting. So for this purpose, we have carbamate over here. And you can selectively deprotect this. So for this purpose, we have AlCl3. If you want to deprotect this TBS, you can also deprotect this TBS by using TBAF, which will only deprotect this OTBDMS. And if you want to deprotect this BOC, so you have to use AlCl3 in place of CH2Cl2. So see, OTBS is as it is, OEC is as it is. There is no deprotection for OTBS and OEC group. It's as it is, right? Then next one is EPMOC, which is important, right? Which is very, very important in terms of protein or peptide synthesis or peptide protection strategies. So this functional group you can see, right? That's fluoronyl group, and again methyl with OCOCl, right? Again NH2 will react. Again NH2 will react over here. See, again NH2 will react at this CO group and it get protected into EPMOC condition. So it has selectively, again you can use TPAF, okay, and thiols may help you. The next one is protection of diol. So during protection of diol, you can use ketone or aldehydes. Different ketones and different aldehydes. Like acetone, you can use acetone, you can use benzaldehyde, you can use formaldehyde. We have different strategy, right? So let's say here we have vicinal diol. So for vicinal diol, we have taken acetone as a protecting agent, right? So it is selectively protect 1,2-diol, simple, and which should be cis. Which functional group? Cis diol. To protect trans diol, definitely ring fusion will be very, very hindered. See, we have this example over here. Cis cyclohexanol, right? Cis cyclohexane 1,2-diol. So for protection purpose, we have used keta. Rather than acetone, we have used ketal in acidic condition. So it will protect this 1,2 cis 1,2-diol. Okay. And for protection purpose, it will stabilize this in basic condition, in nucleophilic condition. So if we have another functional group over here, let's say, you can do selectively reaction over here again. Okay. So protection methodology is important in many organic aspect. So you may use protecting strategy in your research purpose. Another example is here. See, आता यहाँ पे क्या है? What we have here, we have 1,3-diol, and we have taken acetone. Then we have 3 and 4, 1,2-diol. So what is important? We have 1,3 as well as 1,2-diol. Okay. See, acetone is used to protect 1,2-diol over 1,3-diol. At 3 and 4, OH have same stereochemistry. Both are in upward direction, right? And at first carbon, let's say it doesn't matter because it is primary alcohol group. So it may be in above and it may be in below direction. So we have 1,3 as well as 1,2-diol. And if you use this acetone, it will selectively protect 1,2-diol. So if you want to do reaction at this first carbon, or you have to do certain oxidation at first carbon, and you don't want to oxidize this second and third and fourth carbon oxygen. So you have to protect it by using acetone. So first you have protected this acetone, then you can do oxidation. So if you do oxidation, this OH will get converted into aldehyde, and other remaining part is as it is. So remaining part will be as it is. Okay. So that part will be as it is in our moiety. So it will not get affected by any other reagent. Okay. Same strategy is used in this example. Okay. You have used 2 moles. It is selectively deprotected. selectively protected. See, 1 and 2 and 1 and 2 diol. So acetone is used, or this dimethyl acetal ketal, dimethoxy ketal is used to protect 1,2 diol. Okay, 1,2 diol in presence of 1,3 diol. So this strategy is important. If you want to protect 1,2 diol, you have to use acetone as a protecting group. And if you want to use 1,3 diol, you have to use benzaldehyde as a protecting group. See, definitely benzaldehyde can protect 1,2 as well as 1,3 diol. We have benzaldehyde in acidic condition, so it will form you acetal, right? Benzylidine acetal, it will form benzylidine acetal. Let's say we have 1,3 diol, so it will selectively protect this 1,3 diol. If you have 1,2 as well as 1,3 diol, then this benzaldehyde will protect only 1,3. Okay. Okay, online. So let's say we have one example. We'll see here. Let's say we have this example. And you are using this benzaldehyde as a group, protecting group. So what will happen? It will selectively protect. It will selectively protect this 1,3 diol. So there will be protection of 1,3 diol in presence of benzaldehyde. Just we have seen in this example. In presence of 1,3 diol, ketone protect what? It protects 1,2 diol. This 1,2 diol it have protected. And in presence of, in this example, what we have seen, in presence of 1,2 as well as 1,3 diol. So 1,3 diol get protected if you use benzaldehyde. So you have to use different strategy for protecting purpose. Okay. So any doubt online? I guess PPT is over. Any doubt?
Now the session is open for question answer. If you have any question regarding this topic, then ask. Any question?
Hello.
Hello.
I think participants don't have any question.
Okay, sir.
Okay, sir. Now we move on our vote of thanks for this session. Thank you so much, sir, Kishan sir, for your valuable session. I sincerely thank you to our college principal, Dr. B.H. Jagdale sir, for kind support and encouragement for this organizing program. I am also thankful for the coordinator of this program, Professor Dr. T.B. Pawar sir, all the teachers and research scholars for their help and contribution, which made this course successfully. Thank you so much.
Sir, thank you.
Oh,
Yes, sir.
मॅडम मीटिंग एंड करून द्या. रेकॉर्डिंग स्टॉप करून.
All the participants left this session. Now the session is over.